Hello everyone, in this tutorial we are going to create an atlas that contains several decals and apply them to our meshes. And in the end, our street achieves this level of details using only a single atlas. For example, we can use Substance Designer to create cracked details like this. But first, we need to import an empty plane into Substance Painter. Enable the shader you see here, and from the texture set setting, add the opacity channel and set it to 0. At this point, there is an important thing I should mention. This method is a bit different from regular decals. A standalone decal can have more advanced and flexible features, but each decal is built from its own texture set, and if we use them individually, our texture pool size will be filled unnecessarily. Now we can create fill layers, and by using their maps, we can create cracks like this. Also change the fill mode from repeat to none, so we can place the decal in a specific corner. In the same way, we can arrange these cracks together with good variation. We can also use ready-made textures and add damage details like this. Inside Substance itself, we can create these decals either by painting manually or by using filters. We just need to add fill layers and use different ground maps to achieve the result we want. Or we can even sculpt in ZBrush, create an alpha from the mesh and import it into Substance Painter. We can even create decals such as puddles, and by adjusting the roughness and metallic values, achieve convincing water effect. But in my opinion, the best and highest quality method is still using Substance Designer because it gives us excellent quality result. I add several more signs and effects to our atlas so we can build a solid decal set. In the end, I reached a set like this, and I'll upload it for download on our channel. By joining the membership, you'll be able to download it along with the other files as well. For exporting, it's better to use the PBR preset, but it doesn't give us an opacity output. So we go into the output template section, duplicate the PBR output preset and give it a new name. Then we add a gray map, assign the opacity channel to in grayscale mode and choose a name for it. Now we have all of our maps ready. Now we create a separate mesh for each decal, and then in the UV settings we adjust the UVs so they perfectly cover the specific decal we want. In Unreal Engine, I imported all of the meshes, and we'll take a look at a few of them together here. I also created the materials, which are actually the most important part. So let's take a look at the main material that was created. In the base color section, if we connect it directly to the material input in the normal way, it appears too bright. So I use the R output from the height map, strengthened it with a power node, and then multiply with a value of 0.50 to give it a darker tone. If the video has been helpful so far, please support us by liking, commenting, and subscribing to the channel. If I increase the intensity too much, it would create bad result on some of the decals. Of course, if you need more control, you can turn the multiply input into a parameter, create a material instance from it, and assign it to your mesh to achieve a stronger darkening effect. Now to create a fake displacement effect, we use the world position input. We use the R output from the height map, apply a power node to it, and then limit it using a clamp node. We also create a parameter using a scalar and connect it to the clamp through a multiply node. Finally, we add a vertex normal WS node, which defines the normal direction of each vertex in world space. And in the end, you can see the final result. For the roughness, if we connect the roughness node directly to the material input, this would happen. So we need to use a mask, and here I use the metallic mask. First I connect the R output of the roughness to a 1- node to invert it. Then I connected it to a multiply node with a value of 3 to increase its strength. Then I connected to a clamp node, and after that to the A input of a lerp node. For the alpha, I used the output of the metallic mask, and I lowered the B value to minimum amount. Finally, I connect the output of the roughness input. For the metallic itself, I simply connect its output directly to the material input. Although I should mention that I wasn't satisfied with either this puddle material or the version we created inside the atlas, and we'll improve that later on. For the ambient occlusion, I took an output from the R channel of the height map, multiplied it by 1- and then used several multiplied nodes to add darker details into our details. For the puddles material, I used different system and it gave better result. In this setup, I connect the texture to the materials in a much simpler way. As I mentioned before, I wasn't satisfied with the puddles inside the material itself. So I used alpha textures like this and replaced them inside the material. Now we can finally make our street look much more realistic. Thanks for watching. If you enjoyed the video, please support the channel by liking, subscribing and sharing.